Over the next decades, technologies for virtual reality are going to become significantly more advanced. But how advanced will virtual reality become after hundreds or thousands of years? And what would be the most logical path to get there? This video will explore those topics. In 2030, 8K VR headsets are commonplace. By 2030, the latest VR screens now have 8K resolution, which has 4 times the number of pixels as 4K screens. When you view character models and objects up close with these devices, there is zero visible pixelation, resulting in breathtaking detail and realism. Because of other equipment upgrades, VR games also have near zero latency and a wide field of view. Additionally, some haptic suits have become electrode meshes to maximize comfort and convenience. In 2030, many headsets now include the option for brain-computer interfaces to record users' electrical signals and enable actions by merely thinking about them. Headbands and wristbands with non-invasive sensors have become the preferred choices for mainstream brain-computer interface use. These devices scan beta, gamma, and other brain rhythms involved in problem-solving and orientation activities and converts the wearer's mental intentions into actions. The brain-computer interfaces themselves do not process the signals. They send those signals to consoles that decrypt the data. Game developers and VR content creators also have the ability to track and analyze the emotional states of users who volunteer the information. This allows these companies to create more compelling experiences with their content in the future. However, these devices have limited functionality, and there are still some issues with controlling objects in virtual environments and video games. In 2030, virtual worlds are considerably larger than ever. Extremely large and highly detailed VR worlds are now possible. This is largely due to the emergence of 6G, which is 100 times faster than 5G and runs at 1 terabyte per second. This is critical since higher numbers of VR users are now using cloud gaming services. In 2050, 16K virtual reality headsets are mainstream. By 2050, most headsets now come with 16K resolution as a standard, which is 4 times the number of pixels as 8K displays from 2030 and more than 16 times the pixel count of 4K devices from the early 2020s. The 16K format offers a photorealism that is practically impossible for the human eye to distinguish from the real world. Meanwhile, a mid-range graphics card has more than 10 petaflops of processing power, which is 1,000 times more powerful than high-end graphics cards in the early 2020s. In 2050, brain-computer interfaces have improved by orders of magnitude. All virtual reality headsets come with brain-computer interfaces of some type. The somewhat niche and experimental brain-computer interfaces in the 2030s are being replaced by much more sophisticated versions, making brain signal data less noisy. Brain-computer interfaces now offer a bi-directional exchange of information. These advanced neural interfaces send waves to the brain, transmitting visual, audio, and other sensations to the user. The images and experiences generated by these devices are almost indistinguishable from reality, and they're unique to each user because they depend on the structure of the brain. You can easily manipulate any object in the game using your brain signals. This feature is particularly important in the latest Star Wars game, where you play as Jedis and Siths with Force abilities, and in the latest Matrix game, where you play as the One. Additionally, these devices allow people in VR games and experiences to communicate with each other using relatively simple thoughts. However, it would take more decades before this feature is refined. In 2050, virtual worlds are vastly more realistic. With the release of Unreal Engine 8, it's easier and faster than ever for game studios and independent creators to build large and realistic virtual cities that are fully explorable in terms of shops, office spaces, and most other types of interiors. Likewise, an entire forest can now be rendered with sub-millimeter precision, showing unique and random features such as individual leaf marks or insect bites. This variety and realism is apparent in character models as well. Generative adversarial networks can generate an almost infinite variety of each physical attribute, such as faces, hair, body types, and clothing. This is made possible because of enormous amounts of visual data fed to these neural networks. This technique also improves character gestures, expressions, and actions, making them more fluid and lifelike. At this stage, character animations aren't 100% realistic yet, but they are jaw-droppingly close. And with the latest version of MetaHumans, it's relatively easy to build hundreds of unique, non-playable characters at a time that each have unique personalities and life stories. Additionally, thanks to a modern version of a language model similar to GPT-3 from the early 2020s, non-playable characters can now generate and sustain natural, nuanced, and indefinite conversations with the use of powerful and responsive deep learning algorithms in the cloud. Audio in general is richer, more atmospheric, more varied, and realistic. Sound waves can be manipulated in exquisite detail as they bounce around virtual environments and are influenced by different objects, surface textures, and weather conditions. Grand Theft Auto 8, which includes a VR mode, uses much of this technology, and on the first day of its release, it made billions of dollars. In 2050, VR glasses feature multiple display modes. Those display modes include the following. The augmented reality mode will allow the lenses to be transparent so that you can view holograms. The mixed reality mode will allow the lenses to be transparent as well so that you can view hyper-realistic virtual objects in the virtual world that seem to obey the laws of physics. And the virtual reality mode has an opaque coat of silver over the glasses so that you can fully immerse yourself in a virtual world. In the augmented and mixed reality modes, you can view a smart stream where you can manipulate multiple apps and files using your brain activity. The ear sets that come with virtual reality headsets are almost invisible and work using bone-conducting technology. VR contact lens is another area that is gradually being adopted. In 2050, realistic touch, smell, and taste are now possible in virtual reality. Haptic suits now work using exoskeletons to simulate touch, or they may stimulate nerve endings to cause muscle contractions. Because of this technology, you can feel sensations such as cold and heat on precise body regions with sub-millimeter precision. You can clearly differentiate between being punched or caressed in a virtual environment, and you can feel the sensation of a gentle breeze or the sensation of swimming through a virtual lake. In addition to haptic technology, smell and taste are digitized as well. Digital smells and tastes are beginning to be added to virtual environments and are accessible using signals from brain-computer interfaces. And in 2050, real locations are being used for VR experiences. As part of a massive effort to build profitable ecosystems in the metaverse, multiple companies have created entirely digital versions of real cities and locations. This allows smoother continuity between location-based holograms in the physical world, actions made in the associated virtual world, and vice versa. Advances in GPS, 3D scanning, and AI technologies made this possible well before 2050. In the year 2100, full immersion virtual reality becomes mainstream. Full immersion virtual reality involves injecting tens of billions of nanobots into the brain that are programmed to function simultaneously. These nanobots are too small to disrupt the electrical signals in the brain, and it won't cause harm due to their limited functionality. Nanobots work by blocking all sensory information and downloading alternate information to the five senses. In other words, sensations like vision, hearing, smell, taste, and touch are temporarily substituted by a computer program. As a result, VR experiences are now indistinguishable from reality. In the year 2100, all VR experiences have photorealistic graphics. Decades after non-VR video games became photorealistic, all VR experiences are capable of being 100% photorealistic as well. This is due to the fact that $1,000 of computing power is now equal to a billion Earths worth of human intelligence. Laptop-sized computers in this year can perform the equivalent of all human thought over the last 10,000 years in less than 10 microseconds. In 2100, characters in virtual worlds and video games are just as intelligent as real humans. It's now becoming commonplace to encounter characters in virtual worlds and video games that exhibit human-level intelligence. These characters can perform a wide range of activities, creatively problem solve, and exhibit lifelike emotion. At this stage, even artificial general intelligence is starting to become possible for non-playable characters. In 2100, virtual worlds are now planet-sized. Advances in memory, internet speeds, cloud computing, and other areas now enable planet-sized virtual worlds to be commonplace. Because of the partnership of several companies over decades, many of these worlds are now modeled after planet Earth, with numerous alterations applied to them, like size, landscape variations, and time periods, to make these worlds more interesting. This development revolutionizes open world and role-playing games. In the year 3000, entire virtual worlds are constructed using the smallest quantum units as building blocks. As the computing power for supercomputers reached the zettascale, yottascale, and beyond, smaller and smaller pixelations were being applied to greater and greater volumes of space-time. It's now possible to replicate every single subatomic particle in a real environment and the countless quantum events that occur in those environments. Objects in virtual environments, including the air, are now comprised of individual molecules and atoms, and physical forces such as gravity, electricity, magnetism, air resistance, and more now function the same in virtual environments as they do in real life. This offers a level of realism that was inconceivable with full immersion virtual reality by itself. In the year 3000, humans were able to transform virtual environments with their thoughts. Thanks to multiple scientific breakthroughs, it's now possible for people to instantaneously transform multiple dimensions of objects at almost the atomic level using only their thoughts. This development leads to an explosion of creativity and innovation that was inconceivable to people in earlier centuries. To people from the 21st century, the virtual worlds in this era would far surpass the most epic movie environments they ever watched and offer an unimaginable level of detail, ingenuity, and originality. And reality in these worlds is able to change in ways that can't be adequately explained with words from previous centuries. Research is even underway that will allow humans to become virtual environments by connecting their consciousness to those environments. This would allow people to instantaneously rearrange the atoms anywhere in a virtual environment with only their consciousness. In the year 3000, characters in virtual worlds are capable of superintelligence. Characters now have a wide range of intelligence levels. Not only is it normal for characters to have human-level intelligence, but some of them have considerably higher intelligence than humans. Humans now require intelligence and memory-boosting implants to comprehend these characters and the worlds they live in. In the year 3000, digital immortality is commonplace. For a few centuries now, the average person has had access to special clinics where they can upload their consciousness to computers so that their consciousness can live on long after their physical death. Many people choose to have their consciousness transferred to simulations before their physical bodies die, allowing their digital selves to live forever in those simulations. By now, many of these people have lived in these digital simulations for at least a few centuries. In the year 10,000, a simulated universe has been created. This simulated universe has similar laws of physics to our own universe. Some people are granted access to enter and leave this universe as they please, as long as they don't disturb the civilizations that live in it too much. It's become routine to run experiments on artificial Earths in this universe, slightly alter parameters such as gravity, mass, temperature, and so on, then fast forward billions of years to compare outcomes. Intelligent species evolving on those virtual worlds may be entirely unaware that they're part of a giant simulation. Thanks for watching. Make sure to watch the video series to the right about technologies in future time periods.